Alright, 4.4, interior and exterior angles of triangles. Objective, students will be able to use properties of interior and exterior angles of triangles to solve problems. So, first thing that we're going to talk about here is the triangle angle sum theorem. This is talking about the interior angles of a triangle. Triangle literally means three angles, and so we're going to talk about these three angles. Well, one fundamental rule of triangles is that all three of these angles will always add up to 180 degrees. There's no way to draw a triangle where the angles don't all add up to 180. If you got a piece of paper at home, you could pause this video in just a second, and you could take a piece of paper, cut a triangle, any triangle out of it. Then, once you got a triangle cut, rip out the three corners of that triangle, place them together, and they'll make a straight line because they add up to 180 degrees. Doesn't matter what size or what, the dimensions of your triangle, it'll always work. So with that in mind, we can use this to solve some problems. First example here says, find the measure of the three missing angles in the two triangles to the right. Well, we have two triangles here. And so we can zoom in here. We could find angle 1 first because we know these three angles should add up to 180 degrees. That's the property of the interior angles of a triangle. So we could write a real simple equation. We could say 46 plus 41 plus angle 1 has to equal 180 degrees. So 46 plus 41, well, that's 87 plus angle 1 equals 180. And then we could just subtract 87 from both sides. Once you do that, you get that angle 1 equals 93. And so we found angle 1 using that property. Well, if angle 1 is 93, these two angles right here are what we call vertical angles. And we learned a couple videos ago that these two angles must be congruent. So we're just going to say angle 2 is also 93 degrees. Okay, well, now I have two angles out of three. So I'm going to use the same property I did here and say these three angles have to add up to 180. So I can say that 93 plus 24, should be a plus, 24, plus angle 3 has to equal 180 degrees because they're three angles of a right triangle. 93 plus 24, what is that? That's 97 plus 20 is 117 plus angle 3 has to equal 180 degrees. Go ahead and subtract 117 from both sides. And you get that angle 3 equals 63. 63 degrees. So now we've found the three angles of this triangle. Just by using this basic fundamental property that the three angles will always add up to 180. So here's a similar problem. I want you guys to try it. Again, you're going to start with angle 1, then find angle 2, and use that to find angle 3. So go ahead and give it a shot. You may want to pause the video and then check the answer in just a second. Okay, so did a little math here, and we can see that angle 1 has to be 101 degrees. Therefore, angle 2 is also 101 degrees. And therefore, angle 3 is 48 degrees. Now, I want to point something out. This angle here does not look like it's 41 degrees, yet it says that it is. Therefore, it is. This angle here looks acute, but it's actually 101 degrees. What I want you to understand here is that sometimes the drawings cannot be to scale. So don't use the drawing to tell whether your answer is correct or right. Use the information, okay? Because the fact that these angles look acute doesn't mean that it is actually acute. All right, same thing here. And angle 3 is 48 degrees, but it certainly doesn't look like it. It looks like it's actually an obtuse angle, but according to the math and according to the information, it's actually acute at 48. So trust the numbers, trust the information, don't trust the way it looks. Okay, let's go to the next page. All right. Now let's talk about the exterior angles of a triangle. The exterior of an angle polygon, this is an angle formed by a side and an extension of an adjacent side on the outside of the triangle. For example, here you have a triangle, here's a side, and here's an extension of the adjacent side, and so we get an exterior angle here. Okay, so we're actually talking about extending the line and the angle between that extension and the adjacent side. The remote interior angles then, when we're talking about angle 4 as an exterior angle, the remote interior are the two non-adjacent interior angles. So if I'm talking about angle 4 here, angles 1 and 2 would be the remote interior. That means that they are not adjacent, they're not touching angle 4, and they're on the inside of the triangle. See, 3 is on the inside of the triangle, but it's touching. So non-adjacent means not touching. And so we have another theorem here about the exterior angles of a triangle. So we have the triangle exterior angle theorem, and it simply says this: the measure of each exterior angle of a triangle equals the sum of the two remote interior angles. So there's a few things we could do here. If we knew 1 and 2, we could figure out 3 by subtracting it from 180, and then we could subtract that from 180 to find out angle 4. But the point that they're telling you is you can skip that step and just say, you know what, these two have to add together to equal this exterior angle, because these two add up to 180 and these 3 add up to 180. Therefore, these two have to be the same. When I say these two, I mean this angle and these two combined. So I take that to example number 2. We could work out some problems here. What's angle 1? Well, it's an exterior angle to this triangle, and these are remote interiors. So all we have to do to find angle 1 is add these two up. Again, we could find this angle by subtracting this sum from 180 and then subtracting that sum from 180 to get this angle, but we could just skip that step and add these together, and we find out that angle 1 is actually 128 degrees. Well, then angle 2 would be its supplement, because this is a straight line. Its supplement then, what's 180 minus 28? Isn't that 52? And now we have another version of this exterior angle theorem. We know that these two have to add up to equal this exterior angle. So we could kind of just say, if these two have to add up to 120, I could write a little equation. I could say that 52 degrees plus angle 3 has to equal 120 degrees, and that means that I could subtract 52 from both sides, and I would solve for angle 3. So angle 3 equals 120 minus 52, which is 68 degrees. Okay, so angle 3 is 68. I'm just going to put that right here. All right, well, I'm going to let you guys try and finish this. I want you guys to try and find angle 4 and angle 5. I think you'll be able to do it using these properties. Remember that the two remote interiors add up to equal the exterior. You have two remote interiors. They add up to this exterior, and I think you can find angle 4 and then find angle 5. So go ahead and give that a shot. You may want to pause the video and then just check back for the answers in a second. Okay, well, these two have to be supplementary because they make a straight line. So 120 plus 60 makes 180, so angle 4 has to be 60. Angle 5 is an exterior angle. These are two remote interiors, so we just add them together. It equals 116. And there we found all those parts. All right, summary. We've learned about the different classifications of triangles, but can a triangle have more than one right or obtuse angle? Explain your reason. Let me know what you think. I'll see you guys in the next video.